Alright, this is the lecture for 7.3 and for 7.4. We're going to talk about in 7.3, we're going to talk about graphing different types of functions. And as I go along here, I'm going to insert a couple of things from 7.2 that we haven't gotten to yet for those of you listening to this video. And we eventually will get there on Thursday when I discuss it with you, but I'll just go ahead and add them in here as I'm talking about this. So we're going to talk about different types of functions, as I said, and we're going to talk about graphing these different types of functions. So you have two approaches that you can take for graphing these different types of functions. The first approach that you can take to graph these different types of functions is, if it's a linear function, we spent time in Chapter 3 talking about how you graph a linear function. And as we discussed Tuesday in class, if you want to graph something with the form f of x equal to 7x minus 5, well, that's also the equivalent of saying y is equal to 7 times x minus 5. And as we discussed back in Chapter 3, we can use the slope, which for us is 7, but if we're going to use it to graph, we want to write it as a fraction as 7 over 1. And we can use the y-intercept, and the value of that y-intercept, the y value at the y-intercept is negative 5. So we can use the slope and we can use the y-intercept to graph this line. So first of all, as we did back in Chapter 3, we graphed the y-intercept, which is negative 5. So I'm going to go down 1, 2, 3, 4, 5 units on my y-axis. I'm going to get as close as I can to the point. Writing with this pen, I will be off just a little bit. And then my slope is 7 over 1. So from the point down there at 0, negative 5, I'm going to go up 7 units. So up 5 would put me back at the origin. So up 2 more would put me at 7, and then over 1, and I can put me a point there. And then I can connect those 2 points. And I have my line there written and graphed in y equal to mx plus b form. Now, as we're going to discuss a little bit more in detail on Thursday in 7.2, this is a linear function, and anything that's written as the equation of a line is basically a polynomial. So from this equation right here, from the fact that our equation is f of x, or y equal to 7x minus 5, from that I immediately can tell you what the domain of this function is. I can immediately tell you that this function, since it's a polynomial function, my domain is all real numbers, which if you write all real numbers using interval notation, that's what it would look like. It's the entire real number line on the x-axis, everywhere, everything from negative infinity all the way to positive infinity. So you can get that just from the equation, you can get the domain. Now, if I also wanted to find the range of this function, then basically I have to have my graph in order to figure out range. Now, if I look at my range, if I look at where my graph covers the y-axis, then my graph, if I look vertically, it goes forever in both directions. I mean, it's continuing all the way up to positive infinity and all the way down to negative infinity. So as far as my range is concerned, my range here is also all real numbers. So in this case, I have a function where the domain and range are both all real numbers. So equations of lines, you've graphed equations of lines, so you would do it exactly like you've done before. And again, the domain you should be able to get just from looking at that equation. And then the range, doing enough practice and looking at enough examples, you'll be able to tell that the range, looking at that graph, is all real numbers as well. All right, so let's move on to a different type of function. So there's another example of a linear function. So you would use a slope, use the y-intercept to graph that line. So that one works just exactly like we just discussed. So I'll skip that one. And you can either practice that one, or you don't have to have that one filled in when I check your notebook, either way. And so let's talk about the line f of x, or y, equal to negative 6. So y equal to negative 6, that is also the equation of a line that we discussed back in Chapter 3. And anything of the form y equal to a number, like we have here, that is going to be a horizontal line. So we can graph, just from looking at that equation, we can graph y equal to negative 6. So I get on my graph and go down to where y is equal to negative 6. I'm going to go down 1, 2, 3, 4, 5, 6 units. And from there, I'm going to draw me a horizontal line that goes through that point, that goes through at y equal to negative 6. So this is the equation of a line. This is a linear function, which basically is a specific type of polynomial function. So immediately, just from looking at that equation, I can tell you that the domain of my function I don't need the graph to determine this. Just from that equation right there, I can get that the domain of my function, since it's linear or since it's polynomial, is going to be all real numbers. Everything from negative infinity all the way to positive infinity. Now, if I look at my range, this one is different from the last one. Even though this is the equation of a line, it is a specific type of line. If I'm on this line here, my y value never changes, and that's what range represents, are your y values. So my y values stay constant at -6. So in this case, my range is just one value. And it's the value that we set up there in our equation, which is -6. So my range is one single point. It's just, my range is -6 because of the equation there. And from looking at the graph, if I look at where my graph covers the y-axis, it always stays constant here at y equal to -6. At any point on that graph, the x value is changing, which is why my domain is all real numbers, but my range, my y value, never changes. My y value is always -6. Okay, so you should be able to graph those just from looking at the equation, because we've talked about those two types before. But from the equation, you should also be able to get the domain. Now the range, again, you have to have the picture to get the range, but you should be able to get the domain just from looking at that equation there. So make sure you can do that. Make sure you, from the type of function that you have, you can identify what the domain is. All right, let's move on. So another thing that we've talked about before that I want to discuss with you again, and we did this back in Chapter 3, is how to write the equation of a line. And more specifically now, I'm going to talk about this in terms of function notation. So remember back from Chapter 3 that if you want to write the equation of a line, then you have to have the slope and you have to have the y-intercept. And so we'll use the point-slope formula that we've discussed before to write the equation of a line, that y minus y1 is equal to m times x minus x1. So we'll have to have a point on our line, and we'll have to have the slope, and once we have those two pieces of information, then we're going to be able to write this in terms of y equals mx plus b. And then we'll make it fit the function notation if we need to. Now there's two different types that we're going to discuss. The first type is that where all the information is given you. I mean, they've come right out and told you what the slope is. They've come right out and told you what the y-intercept is, and you're just going to be able to write down your equation. And then for other problems, we are going to have to sometimes use the y minus y1 equals m times x minus x1 to help us write the equation. So let's look at a couple of different examples here. And then I have one that I want to add into your notes in just a minute. All right. It says that a taxi ride costs $2 plus 65 cents per mile. And it says find the linear equation that models the situation, and then find the number of miles traveled if the taxi ride costs $7.85. So this is an example where they've come right out and told us everything that we need to know. So I'm going to let x represent the number of miles. And I'm going to let y represent the cost. Now I've chosen to let x represent the number of miles because that's what's changing on me all the time, are the number of miles that I traveled, because it said that it's 65 cents per mile. So I have everything I need. I have my slope. I have by what my value is changing by every single time, and it's right here. It's changing by 65 cents because depending on how many miles I ride in the taxi, then how much they charge me is going to change because it's 65 cents per mile. So there's my slope, and then my y-intercept is that fixed cost that they're going to charge me no matter what. They're going to charge me $2 no matter whether I go 1 mile, 2 miles, 20 miles, 30 miles. They're going to charge me that flat rate of $2 and then 65 cents per mile. So from those two pieces, I can get the total cost of a taxi ride, and it's as a function of the number of miles. So I can say that y is equal to 0.65 or 65 cents times x, which represents my number of miles, plus what they are charging me of $2. So in that case, they came right out, told me everything that I needed to know. They told me what the slope was, told me what the y-intercept was, and hopefully they're not that nice on some problems, and some problems we're going to have to do a lot more work to help us get that. All right, so there's our linear model. And again, I'm not too worried about the function notation right now. We'll worry about that in just a minute. But there's my linear model that I can use to model this situation. And it says find the number of miles, which for me represents x. So they're asking me to find x if the ride costs $7.85. And that's what I use to represent my y values, was the total costs. So they've given me y. They've given me y. I'm going to have to go through and solve this equation for x. So I can plug in what I know. So if I use my linear model, then I know that my y value is $7.85 is equal to 65 cents times x plus my $2. All right, now I just got to go through and solve this linear equation for x. So I'm going to do some basic algebra to solve this linear equation for x. So we're going to subtract 2 on both sides. So minus 2 and minus 2 on both sides. Excuse me a minute, trying to get a new slide here. All right, so $7.85 minus $2. That's going to give me that $5.85 is equal to 65 cents times x if I subtract $2 on both sides. And now, if I want to solve this equation for x, so make sure, because I still see some of you not bringing your calculators when you come take a test, make sure you bring the calculator with you when you come take the test. So we're going to divide by 65 cents on both sides and divide by 65 cents on both sides. And that gives us that x is equal to, and I need to take my own advice. I forgot to bring my calculator with me. So let me pause this and I will go get my calculator. All right, sorry about that. All right, so we take 585, divide by 0.65, we get x is equal to positive 9. So we had to travel 9 miles in order for the total cost to be $7.85. So again, like I said, sometimes they may come right out and just tell you everything that you need to know in terms of writing this in terms of a linear equation. They came right out and told us the slope, told us the y-intercept, and then I just chose to let x represent the number of miles because in this case I knew that was what was changing on me because of the fact that it told me that it was 65 cents per mile, and then that flat rate of $2. And then I just let y represent the cost. I can use whatever letters I want to use, but I just chose to use x and y here. And then from that, I was able to answer the question, and it said find the number of miles, which I called x, and so I was able to go in there and replace the cost, which I called y, with $7.85, and was able to go through and solve that problem. So